Alright, so this is our review for Unit 4. This is the last time we're going to review for this unit. So we're just going to get started. Again, as the title would say somewhere, do not watch this until you have already actually tried the study guide. The point of it is try the study guide, then watch this video and go to any problem that you know that you missed or that you know that you guessed on. So let's get started with number 1. What is the solution to this equation? So for this one, we have to do distributive property twice before we even begin. On the left side, we've got 1/2 times x and 1/2 times negative 12. So half of x, that's just going to be 1/2 x. Half times 12, well, that's going to be 6. We still have the plus 4 hanging off to the side. Equals 1/3 times 6x. Well, 1/3 of 6 is going to be 2, so that's 2x now. 1/3 of 15, that is now going to be 5. So we've got our problem set up. Start by combining your like terms. The fewer things you have on both sides, the better. So on the left side, we're going to combine -6 and +4 first. And we're going to leave everything else alone. So 1/2 x. -6 plus 4, that's going to be -2, and that equals 2x minus 5. So that's where we're at so far. We then have to get one of our x's alone. It doesn't really matter which one we do. I'm going to subtract 1/2 x from both sides. Minus 1/2 x, so it goes away on that side. Minus 1/2 x. Okay, so that means on the left side of the problem now, I have -2, and on the right side of the problem, I now have, what would that be? That'd be 1/2 x. Now I could write 1/2. I'm going to write it as an improper fraction. I'm going to write it as 3/2 x, and we still have the minus 5. And I guess I might as well take care of that minus 5 by adding 5 to both sides. Crosses that out. So now on the right side, we have 3/2 x. And on this side, we have +3. So what we're going to have to do is right now we are multiplying both sides. We're multiplying that x by 3/2. So we have to divide both sides of the equation by 3/2. Now, you guys should remember, when you divide something by a fraction, like if I divide by 1/2, that's the same as multiplying by the reciprocal, 2/1. So that's how I'm going to write it. Now, you can go ahead and do divided by 3/2, and if you're using the calculator that's available up here, you could change all this to a decimal and do it that way. I'm going to do it the old-fashioned way, by hand with fractions. So I'm going to multiply both sides by 2/3. Multiplying by the reciprocal, it's the same as dividing. So I do that, and that's going to get rid of my fraction on both sides. Problem is, I have to do it to the other side too. I'm doing 3 times 2/3. So 2/3 of 3, that's going to give me a whole number. It's going to give me 2. And if I did this with decimals, like let's say I started over and did all of that before with decimals, I'm not going to go back too far, so that way we save some time. But I am going to go back to right about here. And I'm going to rewrite this in decimal form. I know that's 1/2. So 1/2 would be 1.5x equals, that'd be +3. I could divide both sides of this equation by 1.5 and use a calculator to help me with that. That's fine if I'm going to do that. Just keep in mind, if my answer had come out to be a fraction like these two, that might not have worked out so well. But you can change to a decimal if that helps. For number 2, what is the solution to the equation below? Okay, let's go ahead and do our distributive property on both sides. This is 1/2 times 6x, 1/2 times 10. Lucky for us, it looks like this time we won't have any fractions that we'll be working with. 1/2 of 6x is 3x. 1/2 of 10 is 5. We still have this plus x. equals, that is 9x, plus some distributive property going on, 5 times 1, 5 times minus x. So 5 times negative x is negative 5x. Now let's combine stuff. We're going to combine my x's on the left side, so 3x plus 1x. We've got 4x plus 5 on the left, equals, we've got 9x plus 5 minus 5x, and positive 9x gives me 4x. We have plus 5 on this side. So already you should be able to see something. 4x plus 5 equals 4x plus 5. Technically speaking, right now, our problem is done. Both sides of the equation equal the exact same thing. What I want you to think about is, can I replace x with anything? Or everything? Yeah, I could replace x with a 2 and it's going to work, because then both sides will say 4 times 2 plus 5. I could replace it with a decimal, I could replace it with the fraction, I could replace it with pi, I could replace it with whatever I want. It's always going to work. No matter what I put, it will always work. There is an infinite number of solutions to this problem. That's what's happening. When both sides of the equation are perfectly balanced and equal exactly the same thing, then there is an infinite number of solutions. And that's what happened in number 2. For number 3, it's asking for a solution for this one. Again, fortunately, no fractions or decimals. Keep in mind the fractions and decimals, they happen, but they're not the bulk of the test. 4 times x and 4 times net minus 3. Keep in mind that minus. 4 times x is 4x. 4 times negative 3 is negative 12. We still have that plus 5 hanging out to the side. Equals, distributive property on the right side, 2 times 2x, that is 4x. 2 times minus 1, that's going to be minus 2. And then we still have that plus 7 hanging out to the side. Okay, let's go ahead and balance everything out. Combine our like terms here. We have negative 12 plus 5. That would equal negative 7. So we got 4x minus 7 equals, we've got, let's see, 4x negative 2 plus 7 would equal positive 5. Already you should see a warning flag, because something similar happened in the last problem, but slightly different. See, this time, when I go to balance this problem and I subtract 4x from both sides to get the x on one side, what's going to happen is both of them cancel out, and my problem ends up being negative 7 equals positive 5. There's nothing I can do to this problem that would make that true. That is always going to be wrong, no matter what I do. That means there's no solution. There is nothing that I could put in for x that would make this equation work. There is no number that will ever make this equation true, therefore, no solution. That's what this looks like. Infinite solutions means it's perfect on both sides. No solution means you have like something weird that doesn't equal the other side. That's the difference. For number 4, finding perimeter, but with variables. Remember that perimeter is adding all of these sides together. If it helps, write in the rest of it. 2 plus x feet. We are adding all 4 of these amounts. We are adding, let's see, we are adding 3 plus 3 plus, you can really erase your parentheses if it's all addition, 2 plus x plus 2 plus x. And that's going to equal, it said the total perimeter, I can't actually really see it, that line's blocking it, 28. This is our problem. It isn't really 2 variables on both sides of the equation problem, but it is a critical thinking solving equations problem. That's why I've been throwing a few of these in when we've been working throughout the past couple weeks, because sometimes this weasels its way into this unit. So we've got, plus I'm pretty sure I have seen this problem show up for like the past 3 EOGs when I've looked at the 2016 and 2015 EOGs, the released versions. This type of problem's always there. So let's see, when we go ahead and add all of our like terms together, so I'll add all my constants. So 3 plus 3 plus 2 plus 2, that would equal 10. So we've got 10 plus, we've got x plus x, that's 2 x's, equals 28. Cool, let's just go ahead and solve it now. Subtract both sides by 10. We get 2x equals, that is 18 now. Divide both sides by 2. And we end up with x equals 9. That's going to be my value of x. Not really much more to say about this problem. Let's go ahead and clear that and move on. For number 5, what is the value of x in this equation? I think this might be the easiest problem I put on the whole thing. So we've got 8x plus 12. I don't even have to rewrite this. There's no like terms. This one's just super easy. I'm going to start by subtracting both sides by 4x. Just get the x on one side of the equation. And I end up with 4x plus 12 equals, that'd be negative 8. Okay, we'll go ahead and subtract both sides by 12. We have 4x equals negative 8 minus 12. That number is going to become more negative. Negative 8 minus 12, it goes continuing down to negative 20. All right, from this point, we have 4x. We got to divide both sides by 4. And that leaves me with x equals negative 5. That's going to be my answer for number 5. X equals negative 5. Let's go ahead and go to number 6. Number 6, an inequality problem. There aren't as many of these problems as I thought there were. I can't remember which version I looked at, either the 2015 or 2016 version of the EOG, but one of those versions just did not have very many of them, and the other one did. So I'm thinking maybe it started to get phased out of 8th grade. I don't know. Maybe it got moved to a different section. We'll see. For number 6, we're going to start by combining like terms. So I'm going to combine my x's on my left side and combine my constants on my right side. So on the left side, x plus 2x is now 3x plus 4 is less than or equal to, let's see, 5x, and we have 20 minus 32. That's going to be negative. That'd be negative 12. Okay? For starters, we're going to put our variable on both sides, so I'm going to subtract both sides by 3x. Because I don't like dealing with negatives if I can help it. And subtracting 5x by 3x, that won't be negative. So we have 4 is less than or equal to 2x minus 12. We're going to add both sides by 12 to isolate my variable. Forgot how symbols work for a second. So that is going to give me 16 is less than or equal to 2x. Divide both sides by 2. And I get 8 is less than or equal to x. That's what I was looking for, but my answers are all backwards. They have x on the left side, so I have to write this backwards. This says, if I read it, going from right to left, it says x is greater than or equal to 8. That's how I read it if I go from right to left. So x is greater than or equal to 8. So the alligator is eating the x. That's what we're looking for. I know that can be tricky, but it is going to happen. So number 7, we have moved on from variables on both sides to now solving these types. Now the first one, I made it easy for you. It gave you the graph of both of the equations, but this is what you're doing when you're solving systems of equations. You are setting up two lines and finding where they cross. And where they cross, that's your answer. So these two lines cross at -1, 2. That's it. Now the next one is a normal problem that we've seen before. And I already have, this is the website, by the way, geogebra.org/geometry. This is the site you're going to use. I'm going to move myself out of the way so I can show you this. Right over here, you click that, and it's going to pull up these options. Show axis, that's going to show you the main axis. Show grid, major grid lines only. You don't want the whole thing. You just want the major grid lines. That's going to set up your graph so that way you can use it. You can zoom out if you need to see more numbers, zoom in if you need to see less. You can also just grab and move it around, okay? But we're going to set up our two graphs. Our first one, its y-intercept is at -5, okay? So I'm going to put in a line. First dot is at -5, and the slope is 2/3. So 2 is my rise, 3 is my run. So from here, 2 is my rise, 1, 2, 3 is my run, 1, 2, 3. There we go. We have our line. That's the first one. Our second line is at -4, so that's my first one. So -4. Let's look at the slope. Slope is 1/3, so rise over run, 1/3. So my rise is 1, my run is 3. 1, 2, 3. So it looks like they're crossing right here where point B actually is, which is at 3, -3. So 3, -3, right there. That's number 8. Let's go ahead and go back here, and I'm just going to use this undo button to clear it. It's a little bit easier to me. So we've got that cleared out. Our next points are, this first one is, it intercepts at +3, and its slope is 4. That means 4/1. Rise is 4, run is 1. So it crosses at +3, and if the slope is 4, that is 4/1. Rise over run. It's going to rise 4, 1, 2, 3, 4, and run by 1. That's going to be my first line. The second line crosses at +5, so it crosses way up here. And the slope is 2, so that's 2/1. So my rise is 2, my run is 1. So 1, 2, 1. Once again, it crossed like right at the points that I'm actually using. So this one's going to be at 1, 7. That's my answer for this one. For number 10, let me clear my graph. Okay. We've got x -9. So -9, I can't see it. So what I'm going to do is click on move. I'm going to drag my graph down so I can see the -9. So it's at -9. And the slope, it just said x. There wasn't anything in front of there. Remember that if you don't see a number written in front of a variable, that means you should imagine an invisible 1 for the coefficient. That means the rise and run are both 1, just 1/1. 1, 1. That's it. That's what a slope will look like if it's just x. The second one is going to be, it intercepts at -4, and the slope is a 2, so that is 2/1. So the rise is 2, 1, 2, and the run is 1. Alright, so I gotta look around and see where they cross. It looks like they're gonna cross way down here, which is at, that is -5, -14. So -5, -14 is going to be my intercept there. I'm going to go ahead and clear my board by clicking undo. I'm going to click move to drag myself back to the center. There we go. Let's go ahead and get started on the next one. Only 2 left. So for this one, line N is represented by y equals 1/2 x minus 4. Line M is already graphed below. So for this one, They gave us a graph, and they want us to actually create another line on here. Now, if you have a dry erase marker, you could probably do this just fine. Spoiler though, if you have a pencil and you write very, very gently over your Chromebook screen, it will erase perfectly fine. Just be very gentle. So, for this one, my y-intercept will be at +4, so there's my point. And the slope is 1/2. So my rise is 1, and my run is 2. So I rise by 1, run is 2. Rise is 1, run is 2. And you can use this, obviously it's not going to cross up here, but you can tell, oh, it's going to continue going in that direction. So it's going to continue in this direction if I kept going. So if I look, I just continue to follow those dots I'm making, that's where it would end up crossing. It'll cross at -4, +2. Likewise, another thing you could have done was you could have tried to recreate this graph exactly in this GeoGebra. I don't actually know how to say that. I'm not going to fret about it. But yeah, it's going to cross at -4, +2. That's where it would intersect. And last but not least, I saved the hardest problem for last. This one is one of those problems that you have to create 2 lines based on a story. So here's the story. Natasha is renting a room for a party. Whoop-de-doo, that's not important. Room 1 has a reservation fee of $30 plus $10 per room. Okay, so let's think about what that would look like in an equation. Room 1, so we'll say room 1, that is equal to $30 plus $10 per hour. How much is an hour? We have no, how many hours? We don't know. But we know that it's going to be room 1 is $30. It's $30 plus $10 an hour. So $10 per hour. So here's my equation for room 1. It's $10 an hour plus 30 bucks. Room 2 is just $20 an hour, no reservation fee. So room 2 is just going to be 20 bucks an hour. Not 2x, that would be 20x. So here are my 2 equations. We have 10x plus 30, and we have 20x. And we're trying to compare them using a graph to see when they will eventually cross. Obviously in the positives, because you can't have a negative amount. So when I go into my graph over here, I'm going to be looking for something. I'm very specifically going to be looking to make sure that, whoops, I meant to do move, not that. We want everything to be in the positives. Obviously, you can't rent a room for a negative amount of time. That doesn't make sense. I also obviously need to make sure that my graph has like big enough numbers, because obviously I am dealing with numbers in the 20s here. So my first equation for room 1, I already erased it, but the reservation fee was plus 30. Well, so that means my y-intercept is here. If I rent a room for 0 hours, then it's still going to cost me $30 just for the privilege of walking in the door. And then it's $10 per hour. That means for every 1 hour I move over, it's going to go up by $10. So I'm going to need to zoom in a little bit here, so that way I can see down here when this reaches 1. There we go. So it's going to go from $30 all the way up to $40, because I go up by 10 and over by 1. Every 1 hour is going to cost me another $10. So create my line. It intercepts at 30. I go over by 1, and I go up by 10. So there's my first graph. This is for room 1. Room 1, if I zoom way out, is going to look like that. For every 1 hour, this is going to go up by $10 every hour. Okay? Then I'm going to look at my second equation, which it said it's just a flat fee of $20 per hour. So that's actually going to start way down here at 0. That's going to start at 0 hours for me for this one. So for 0 hours, and then it's going to go up by 20 each hour. So I'm going to set up my line. It's going to start at 0. Now I'm going to have to zoom out for this because I can't see where the 20 is up here. So I'm actually going to need to zoom out a little bit, and hopefully I will be able to see where the 20 is. Let's see, where is that 20? This is going to be actually a little hard. So here's my line. Crosses there. And my 1 is probably somewhere right about here. Just about. It's very, very close. I wonder, though, if I hit show grid and show major and minor lines. Well, you know, that does kind of help, doesn't it? I can zoom in a bit and move this over so that it's directly on the 1, I suppose. There we go. So there are my two graphs. I'm just looking for where they're going to end up crossing, how many hours it's going to take before they equal each other. And it looks like the point that they cross, I'm going to have to zoom in quite a bit here. It looks like they're crossing right here, which is going to be, it's going to cost $60, and it's going to be 3 hours. So that's what I'm doing for this problem. Now there is another way you could do this, and this is kind of cheating, but it's something that makes itself available whenever you're dealing with multiple choice problems. If you know room 1, so room 1, you know that that's going to be $10 an hour plus $30. And you know the other one, room 2, is going to equal $20 an hour, period. Well, if you know it has to be the same number of hours, there's another way to set up number 12. $10 an hour plus 30 must equal $20 an hour. If you prefer not to do this using a graph and prefer to do this algebraically, you could have set it up like this instead. So for this one, I'm probably going to give everybody a hint. I'll probably add a hint to number 12, telling people solve it using a graph or by setting them equal to each other. But the choice is up to you how you want to solve it. However you do it, if I do minus 10h, cross that out, I have 30 equals 10h. I think you see where this is going. 3 equals number of hours. Regardless of which way you chose to solve this problem, you will get 3 hours. Admittedly, because of how this graph is set up and the way it works for zooming, it probably going to be easier to do it that way. Let's check and make sure that I didn't mess up the answer key, because I do that a lot. And we'll make sure that this says 12 out of 12, which means that there were no errors. 12 out of 12, no errors, no typos. Took me about 31 minutes. That's including me stopping to explain how to do each problem. So it should take you guys roughly 30 to 40 minutes as well. And well, that's about it. Good luck tomorrow, and I'll see you guys later. Bye-bye.